We want to get under the covers, under the hood of Nuage Networks SDN solution. And we are especially excited because you guys are really steeped into this technology. In fact, you guys are shaping some of the conversations going on in the industry with regards to SDN, with regards to how SDN would help automate data center networks and really build out the next generation software-defined data centers. So, talking about automation, this morning I was with the CIO of a Fortune 150 company. They were here visiting, and he was telling me how they want to automate all their data center assets. They want to automate because they want to provide their customers, their users, very rapid deployment of applications onto the data center. Why? Because they're concerned that the lines of businesses are trying to go past them to AWS, for example, to deploy their applications. And that sends chills down their spine. He wants to build infrastructure, an automated infrastructure that's as automated as AWS is in terms of both compute and network. He was also telling me that what I'd really like is to have a comprehensive policy infrastructure that allows me to really control access. I set a policy. I want to make sure that the policy is deployed across my data center, in every single data center. I want to create service templates. I want to create service templates for different applications. And I want to do them once based on the requirements of the applications. I want to set up the QoS, the filters, the compliance rules. I want to give permissions for what users should be accessing that particular service template. And after I've done that, I want everybody to use it based on the roles and permissions that they have, the users have. I want to do it once, spread it out many times. And most importantly, if we notice an issue in the network or we want to change something, we want to go up to this policy server and change that rule and have it apply across all services instantly, rather than go touch every single asset in the data center. We had a great meeting because what he was doing was describing the Nuage network solution. Nuage Networks is a wholly owned subsidiary of Alcatel-Lucent. We started 18 months ago, and we built a comprehensive SDN solution that we have been shipping since May of this year. And with our solution, what we are doing is we are removing all constraints in the data center by adding programmability and automation in a way that allows for virtual machines to be instantly connected to the network as soon as they come up. As soon as they're created, they're connected to the network. That's how we're removing all constraints in the data center. But when we started Nuage Networks, we started with the idea that the SDN technology that we were going to develop was going to allow to automate for all network requirements of enterprise, not just the data center, for all networking requirements of the of enterprises. So today, we're going to talk and have a meaningful dialogue, go under the hood of the SDN solution that we've been shipping. But more importantly, I'm really excited that we're going to expand. This is the first time we're announcing it in front of you guys. We're going to expand that capability that we have been shipping since May to cover not just the virtualized assets in the data centers, but also the non-virtualized assets in the data center. Because as you all know, in almost every data center, there's a ratio of virtualized and non-virtualized assets. And over time, that might change. But an SDN solution must provide automation and this policy framework across all virtualized and non-virtualized assets. And that's what we're going to talk about today. That's something that Dimitri is going to cover after he's covered the main principal SDN solution. And following that, in a few months, you'll hear from us about how we are taking this technology to then go back to solving other network automation requirements for the enterprises. So having said that, I'm going to hand it to Dimitri, who's going to take us through the detailed discussion.
Hello, everybody. My name is Dimitri Styliadis. I'm the Chief Architect of Nuage Networks. And it's the first time that we get together as part of TechField Day. So what I'm trying to do is, because I think to some of you, the solution and the approach we took is a little new. I'll try to cover the key fundamental components that, or if you want, the ingredients of how the solution is coming together and what it means and what it does. So network virtualization, right? I think at this point, as an industry, we have made tremendous progress. Network virtualization has become something that a lot of people understand because it solves some real problems in the data center. It addresses the capability of, creating virtual machines, interconnect them over, these virtual L2 segments and stuff like that, potentially doing some layer 3. A lot of solutions use, for example, virtual machines as routers and so on. It is tremendous progress compared to a year ago that we're still talking about VLANs, right? At the same time, I think we are at the beginning of the journey. There are significant more important problems to solve, and there are significant ways that this varies, right? And I was actually reading Jason's blog the other day, like 2 days ago, saying what is under the hood, right? From the 10,000 feet approach, they all look the same, but what is under the hood? So I will try to explain to you what is under the hood and how what we are doing, I think, is fundamentally different here. Let's talk about enterprise applications, right? I mean, I showed in the previous picture the whole concept of network virtualization. Well, I want to virtualize a layer 2 segment, and I do these tunnels and so on. We fundamentally believe that in order to make network virtualization deployable in large scale, there are significant more use cases that have to be addressed, right? We are only scratching the tip of the iceberg. And I have some of the standard use cases that people refer to, right? On the first, I have the standard 3-tier application. I think we have seen that over and over again. On the middle there, I have the whole concept of the hybrid cloud, right? We are talking about the hybrid cloud. The question is, how can you have a hybrid cloud without a reliable network infrastructure? And when we're talking about the hybrid cloud, you can have multiple availability zones. You want to spread your application in different availability zones. You have enterprise sites, potentially an MPLS VPN service or a managed VPN service. You want to make everything come together, right? There are even more fancy, I call them use cases, where people are talking about disaster recovery and extending LANs and all kinds of things like that. Potentially, some people have some use for them, not necessarily everybody. Nevertheless, there are questions and issues around that. So in order to address these requirements, we put, if you want, 6 areas that I think they are fundamental on creating this network virtualization. And I'll take you through these 6 areas, and then I'll describe you how we solve each one of these problems, if you want. Now, the first one is the federation and service interconnection, right? People don't build one single monolithic data center. They build multiple zones, the availability zones. They want a shared-nothing architecture between the availability zones, and they need to interconnect them, right? So we have to figure out a way to federate and scale our approach. Management complexity, again, if we solve the problem by introducing a lot of complex systems, a lot of routing protocols, and so on, we create more management complexity than what we are removing, so we have to be careful with that item as well. Underlay, right? There has been a lot of discussion. I have seen lots of back and forth going on, right? Does the overlay need to know the underlay or doesn't need to know the underlay? I think we have a clear position here that we need to discuss and explain what are our thoughts or how we are solving some of these issues. Policy and abstraction. Now, it's one thing to say I'm going to virtualize the network. The other thing is what tools am I going to give to the end users, right? Am I going to tell the end users, here is a NoSPF interface. Yeah, fine, it's in an API, but you do any API calls you want to configure SPF, and I'm going to allow them to play with these things? Am I going to give to the application developers rope to hang themselves, in other words? Or do I create the abstractions and policies and hide all these things and essentially allow them to focus where they need to focus, that is on their applications? Visibility and assurance. we create thousands of tunnels or these virtual networks going on around? Well, we need to be able to see what's happening there, right? That's the obvious thing. And the last but not least, physical endpoints, right? Reality is not all the world is a virtual machine. There are a lot of physical endpoints. There are a lot of use cases. I'm sure you know, hosting facilities, colos, all kinds of stuff. You have existing networks. You want to interconnect them. And how do you do this, right? So I'm going to go now through these things and explain the solution across these 6 dimensions, right? So first of all, network virtualization, I'm sure you know that, but I want to give the picture as a reference, right? It assumes an IP fabric as a transport, anybody's IP network as the transport, it doesn't matter what it is. The whole idea is that we start an overlay network on the hypervisors and allow the hypervisors to talk to each other. Now, why tunneling, right? Because there are other ways to achieve the same thing. I think there are 2 reasons for tunneling. The one is people are talking about VM mobility. I think it's the less important reason. I think the more important reason is the namespace isolation. In other words, if I have multiple tenants, I want to give them the ability to move their IP addresses in and forget about other people's, if there are IP address conflicts and stuff like that. I think it's namespace isolation, the more interesting aspect. Now, and then the whole idea is by keeping the core simple, we can scale the core, right? We can make the core network very simple, and we push all the intelligence and the complexity out at the edges, right? So things like ACLs, QoS, access controls, everything is pushed out at the edges. Okay, so this is, I think, understood about network virtualization. The interesting question is what control plane? Because the tunnels or the tunnel formats are less interesting, right? The question is what's the control plane? If I use the purist, if you want, approach, the internet approach, it would say that I put a control plane in every hypervisor, right? So every hypervisor gets a control plane, I run some protocol in between them and so on, and I try to do it. Obviously, if I put tens of thousands of control planes, then it doesn't scale, right? That's the fundamental problem. Nevertheless, it has all the internet properties underneath, right? That's why some would argue this is the right approach. The other approach is the other extreme of the design space, if you want, right? I put a single controller up, and it manages all the forwarding entries in all my hypervisors, right? And this is the traditional, if you want, SDN viewpoint. But let's think about it, right? If it's a controller managing everything, first of all, it has a limit to scale, no matter what. There is a limit on the scale of this thing. Second, no matter how redundant you do it, if it has a fundamental software bug and the controller goes boom, then the whole network is out of service, right? So it's a fundamental fate sharing. Everybody is sharing the same fate, right? So I think it's to a certain extent the other extreme. So what we said is, well, there is a middle way, right? We have solved the same way, the same problem in computer science over and over again, right? It's the whole idea of creating domains and federating them, and federating them in a shared nothing architecture. In other words, this controller and this controller don't share any database. Because if they share a database, then immediately I'm back to square one, right? And the question is, how do you do this federation, right? Do I reinvent the wheel, or do I have a tool to do it already? And what we immediately felt, based on to a certain extent, based on the operational experience that we had with IP VPNs, is there is a very easy way to federate controllers, and that's BGPMP, right? So if I have BGPMP and I federate the controllers with BGP, essentially I have a shared nothing architecture. Now, think of the controllers a little bit this way also, right? I want to give you a visual. You have a big router, and the big router usually has a control plane, it has line cards, and it has a fabric, okay? So what we did actually is we grabbed the control plane out of the service router that we have deployed in all the service provider networks. We grabbed it out and made it a virtual machine. We thought line cards, instead of having hardware line cards in a chassis, they are the hypervisor switches. So now we have the control plane and the line cards. And instead of having a fabric, we have an IP network. So if you think about it, the controller with the line cards and the IP fabric look and feel like a big router. And then this router talks to other routers by using BGPMP. And then in this way, I can start building larger and larger and larger networks. Okay? So the key trick here is now, the reason for BGPMP, and that's not just BGP, right? It's multi-protocol extensions BGP, is the idea that I support BGP VPNs. I can have multiple services running there. I can have overlapping IP address spaces, and I have a single control plane to deal with. Okay? So that's essentially the first part. How do we address federation?
Are you going into more details on that, or shall I start asking questions now?
You can start, and based on your question, I'll see if I'll defer you later or not.
So the first question is, okay, you're using overlays with tunnels. What encapsulation are you using?
Okay. I'll come back to the encapsulations, but basically it's VXLAN.
Okay.
Basically it's VXLAN. But there is a but. I will come back to the but.
What protocol are you using between controller and the hypervisors?
I will come back again to that.
Okay.
But it's essentially OpenFlow and OVSDB.
Okay. And I guess you have redundant controllers for each.
Absolutely.
Okay.
Absolutely. Right. So not just redundant, right? Redundant the way you would have redundant in a service provider router, right? So everything is okay.
And you wouldn't want to have just any mesh of BGP speaking routers. So when you do federation, you use the route reflector?
Yeah, I mean, depending on how much you want to scale, right? I mean, if you want to really scale, you introduce.
It's a classical route reflector problem.
Yes, yes, correct. Same tools, same methodologies, everything. So
extending layer 3 VPNs across multiple controller boundaries is obviously trivial. Can you extend a layer 2 subnet across?
So the answer is BGP VPN.
Okay.
Okay. The BGP VPN SAFI, that is almost an RFC right now, and
okay.
Florin is one of the co-authors there.
Thank you.
Okay.
I'm done.
Okay. Good. Now.
Real quick, did you say OVSDB and OpenFlow between?
Yes.
Okay.
Both of them. Okay. Yeah. Now, let me go to the next thing: service interconnection. Right. Okay. So I'm an application developer. I want to build a highly available application. I'm building half my application in one availability zone, half my application in another availability zone. I need to make the two talk to each other, right? These are two different availability zones. And the question is, how am I going to do that, right? Now, what we have seen people suggest is, well, it's easy. Put a virtual machine router in both of the availability zones, do some type of interconnection between these routers, and it's done, right? Now, yes, it's done for one. Let's try to do it for 10,000 now, okay? If we do it for 1,000 or 10,000, how does it look now? I'm going to have a proliferation of virtual routers running in my data center. I'm going to consume compute resources that are revenue-generating resources in order to do packet forwarding to interconnect between two availability zones, right? So I have thousands of control planes to deal with. I have VM bottlenecks because everything has to go east-west between the VMs, and I have to deal with that. And I'm essentially creating all this complex system underneath, right? So what is the answer here? Well, the answer is very simple, right? Because if you have the two controllers run BGP across them, right? Run BGP MP across them, then this hypervisor will get a route that if this app wants to talk to the app over there, create a tunnel directly from the one availability zone to the other. So essentially, it will propagate all the routes, right? And if you want to put a hierarchy in the middle and put an aggregation or put whatever with MPLS, and I'm going to show an example like that later, then this controller will talk BGP with your with your router over here, that will talk BGP with your router here, that will talk BGP with this controller, and the routes will be propagated automatically. No need for any virtual machine routers anywhere. Everything is completely distributed. Now, one thing that I didn't mention is our hypervisors and our virtualization does both layer 2 and layer 3. And I'll explain that in more detail. But, you know, we can route between different subnets and so on. So that's not an issue.
What's the SDN edge and the provider edge box? Are you going to go into detail?
Yes.
Okay, great.
Yes. Now, the interesting thing is, once I solve this problem, because remember, keep this visual in mind, right? That the controller together with the hypervisors, with the virtual switches in the hypervisors,
it looks router.
As one PE.
Yeah.
Right? But
so you have the PE router and the line cards.
You see it exactly as one big PE, right? Then I have solved this problem, right?
Of course.
This is one PE router that has a bunch of line cards.
Yeah.
Okay, that can talk directly BGP with the existing MPLS VPN network. This is another router that can talk with existing MPLS VPN network. And I'll show you actually in the demo how the two are coming together. And you know, I can talk from machines here to machines there to the enterprise side seamlessly.
You have the encapsulation translation problem.
Okay. Again, you're going to the encapsulation. So here's how you solve that, right? There is the short-term solution, and there is the long-term solution. The short-term solution says that the current PEs don't support VXLAN. However, as I'm sure you are well aware, the current PEs do support VPN over GRE.
Some.
Well,
all support them. Some support it in hardware.
Some support it better than others.
Yeah.
Right. So what we do is, depending on where the route is coming, if the route is learned and we know that the next hop is actually PE, we actually encapsulate the traffic with VPN over GRE. If the traffic is within the data center and we don't need to talk to a hardware PE, then we talk VXLAN.
So why are you using VXLAN for entropy?
We use VXLAN because we strongly believe that there is so much, first of all, there is the entropy thing, that current core networks don't do that. But also there is enough, if you want, inertia in the industry to optimize VXLAN in the servers. You know, all the ways in the stack, including NICs, including everything else.
Offload. Yeah.
Okay? It's going to happen.
For performance.
Yeah.
Right? So from a management complexity, our argument is by using this architecture, a well-tested architecture with BGPMP, essentially there is a single control plane. You put the controllers, they run BGPMP between them. There's a single control plane. You don't need to worry about control planes anymore, right? You don't need to worry about every tenant instantiating a different control plane and creating trouble for themselves, if you will. Now, underlay and overlay. Okay, that's another big, if you want, discussion that I want to go back and think actually on the origins of the internet. You'll say, well, this guy is nuts, but anyway. Why did people choose, first of all, to do in-band control protocols, right? There was a reason. They want fate sharing between the control and the data. In other words, if you lose the data path from the server to the top of rack switch, then you should lose the control path as well. Because if your control path is in a parallel out-of-band network, and you lose the data path there, the control path has no clue about it, right? So it's fundamental, first of all, the first fundamental choice we did is we use an in-band. In other words, the controller talks to the hypervisors over the same network that the hypervisors talk VXLAN in between them. So if we lose the connectivity from the server to the top of rack, we immediately know about it, right? Because we will lose the connection. So the controller knows immediately about it. Now, the problem also, though, is, okay, that is one failure. The other failure is I can lose something anywhere in the network, right? I can lose the underlay. And if I lose the underlay, what do I do about it, right? And if the controller is sitting up there in the cloud without any knowledge of the network, it's completely decoupled from the network, then it has no clue about what happened in the underlay. So what it's going to do in the case of the failure, right? It will lose visibility of what's happening there, and then potentially go in all kinds of situations of sending pings anybody to anybody, figure out what's happening and all these things. So here's the approach we took, right? Nothing new again. The approach we took is the same approach that we have been taking in service provider networks all along, right? So in reality, right, there is a physical world under there in the cloud that conveniently I have as a cloud, right? That is the overlay. So what we do is we actually get the controller to peer with the IGP, whatever IGP is used in the data center, so the controller can peer with actually the physical routers, the physical elements now in the data center, and from these physical elements it recovers the topology. So the moment you have a failure now, somewhere in the topology, right, the moment you have a failure here, at the minimum this controller there will know that if I try to talk from this guy to this guy, I lost my paths. So it's going to withdraw the paths immediately, right? That's the tracking essentially the next hop routes, right? That's a standard thing happening in all MPLS networks. So if this guy tries to talk to this guy, it's not going to black hole the traffic to nowhere, right? The routes will be withdrawn, right? That's a fundamental concept of next hop tracking. Not only that, and I know that Ivan has a question there. I can see him itching.
You know exactly where I'm going, right?
Okay. Not only that, because not all cases are covered by this, right? But at the minimum also, by having this visibility, by having the peering and the visibility, once we detect a failure, because in reality, the core fabric, right, it doesn't look like that, right? It's a leaf spine architecture, it's fully redundant. A failure in the core is not going to affect anything. It's going to reduce capacity. what the controller will do is raise an alarm in most cases and tell the virtualized services that I'm going to affect you. Go ahead, Ivana.
Yeah. Now, the problem is that if you lose a core link, then you're absolutely correct.
Yes.
If you lose a link to the server,
Yes.
then that's hidden because of subnet aggregation.
Remember what I said about in-band. The server talks over the same physical link to the controller app. So if I lose that, I lose the TCP connection.
The controller knows about that.
Right? So the controller loses the TCP connection to the server, and that goes away. Okay? Yeah. So we're addressing the problem with standard techniques again, right? There is no reason here to say, I want these switches to be my switches, my management protocol, my interfaces, whatever, right? This is anybody's switches, is over standard protocols, right? So we're trying essentially to marry the two worlds here.
Now, since you have two links coming out of the hypervisor, I can't resist this question.
Okay.
If you have two physical links going to two top-of-rack switches, do they have to share a VLAN, or can you support two IP addresses on two uplinks?
Right now, we made the simplification assumption of assuming these are lagged.
Okay. Yeah. Too bad.
I don't think it's an issue, though. It's because everything is IP. In reality, it's not an issue. It's just a matter of testing, right?
So are you? Oh, sorry, go ahead, Bob. So your multiple controllers there that are doing MPBGP between, are they exchanging just reachability information, or are they exchanging policy information as well?
They are exchanging just reachability information.
Okay.
Okay.
So if you've got,
I'll come to policy. Policy is handled in a different way. It's not. We don't propagate ACLs over BGP, right? We don't use this type of stuff.
Just to be clear, every individual controller that you see in there is the equivalent to an SDN controller, which has on top a communication interface which is based on BGP-MP, but it's a cluster of controllers on VMs that works exactly like what you see today in a one cluster solution, right?
Right, but if you have multiple,
when you go outside,
multiple distinct controllers, now we're going to need a controller.
Yeah,
right?
I'll come to the policy decision.
Okay.
Okay, I'll come to that.
So my scaling question
kind of
from
flow table policy
earlier.
looks like. What are you doing? Table misses. What are you doing with L2 learning? You intercepting it.
Right.
Walk through the packet walk.
I think I have a packet walkthrough. I have a packet walkthrough, but just to highlight, and I'll get back on the packet walkthrough. When a VM sends a packet down to the hypervisor, well, actually, ARPs are immediately responded by us, right? So there is no multicasting to go.
So you have ARP proxy in the hypervisor or in the controller?
The hypervisor is a slave of the controller doing ARP responses on behalf of the controller.
Okay, so the ARPs are effectively terminated in the hypervisor.
In the hypervisor. They are terminated there.
Okay.
Right?
You respond right away.
So, hold on. No, so it is part of the OVS, right? So the traffic coming on the vSwitch, that is, if it is an ARP, it's terminated by an agent in the hypervisor, right? It's responded there. And because of the BGP-MP that advertises MAC addresses, we know all the MAC addresses, so we can respond immediately. Right?
So you're hashing out key values to every hypervisor.
Right. So that's for the ARPs. Now, unknown
only
traffic
for the VMs that are in that hypervisor, right. Obviously.
Unknown traffic, it only exists in a very particular case if you want to go out. If you want to go out in a physical segment, for all the VMs, you don't have unknown traffic. And what we do for multicast and unknown, we also allow source replication. If there is a need for multicast or unknown, we do source replication in the hypervisors.
It would be really cool if you would do something like Juniper is doing with QFabric and also distribute ARP information as another address family.
Okay.
Well, the ARP replication, it is basically, the ARP information is
essentially EVPN, right?
In EVPN SAFI. There is basically the standard way to distribute it.
Oh, okay, that is,
It's part of EVPN, right? Every VPN entry has the MAC address and the IP address.
I mean, every controller has the capacity to just download exactly what you need for those 40 VMs or whatever you have in there.
So, it's already. So the controller is still the master for key value on Mac.
Yes.
Okay.
Yeah.
So unicast replication, or always unicast pulls between. I've heard between hypervisors and from hypervisor to controller.
The controller is never on the data path.
Okay.
No packet goes ever to the controller. The controller, the only thing that does is programs forwarding entries and stuff like that. Never on the data path.
So are you using the standard Open vSwitch or
no? I'll explain it.
Okay.
It's a modified vSwitch.
Good.
Okay? Now, let me go to my favorite topic, right? Because we have Florian here, he's our networking guy. My favorite topic is abstractions, right? So you go into a cloud environment, you try to deliver a service, a networking service. The question is, what are the abstractions and how do you deal with that, right? Do you give all the networking knobs to application developers, and do they care about it? And I went and looked actually at Amazon, right? Remember the problem that I told you I have 2 availability zones, I want to interconnect them, and what Amazon tells you, AWS, you need to put a router here, put another router here, do all the stuff to interconnect, and then you have your virtual machines there, right? This is the standard technique suggested by AWS to do interconnection between availability zones. So I went and see what does it take to do that, right? And this is a cut and paste from their website. You can't see it. It doesn't meant to be read. Don't try to read it. Bottom line is there is a huge page here. It tells you do this, that, blah, blah, blah. Configure this IP address, that route, the other route. Then it has 2 pages of OpenVPN instructions in the bottom. And then it has an appendix. And it says high availability. Okay, it's an appendix. So if you're going to do it in a high availability, you need to put 2 gateways, you need to interconnect them, you need to configure everything. And it's a lot of work. Can any application developer go do all these things? Actually, Human here, our marketing guy, gave me the right quote here, right? It's a jungle in Amazon, right? So, okay.
Look at the grin on his face.
Push the luck. Okay, so, and that's a lot of the typical steps I have seen in a lot of solutions. You want to do any interconnections like that? Configure out routing protocols, match IP address, configure ACLs, blah, 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 blah. And my question is very simple. Do you really want your application developers to spend their time on these things or on writing and solving application problems, right? It's a problem that has to go away. And our idea of abstractions is that from an application perspective, right, what do I want? Well, I want my network. Just give me my network, right? And my network is going to have several tiers, potentially, whatever. I have a policy that says I want from this zone to that zone to go then, and from the other zone to the other zone to go based on these rules. I want to access the public internet, or I want port 80 on the public internet to come to me. I want to go on my enterprise side for my backups. That's my network definition, right? It doesn't include IP addresses. It doesn't include configuring routers and stuff like that, right? So essentially, I define a policy. I define a policy that if you want, the analogy that I do sometimes is like the rules of chess, right? I define the rules of chess, and there are millions of chess games that they can be played with the same rules, right? So what I do is I define a policy. What is the availability I want from each zone? What is the QoS that I want from each zone? How can I want to communicate between different zones? Who can access the zones if I have multiple people working together? And off you go. That's what I need to define, the policy. So based on this, right, I create a whole set of policy templates. I have this policy that applies to my engineering guys. I have this other policy for my ops guys. I have a policy for my finance guys. I have my HIPAA policy. I have my this policy, whatever, right? And then I essentially have 3 things, right? I have my users. I have what type of application they are trying to instantiate. And I have my business rules. And the business rules can vary, but I have my business rules. And based on these rules, I can do a policy evaluation. I get the policy, based on the rules, I do the policy evaluation, and based on the policy evaluation, I start with a whole, if you want, instances of networks that can be created there, right? So it's fundamental that what we expose is policy. What we expose is simple policy concepts, and not necessarily, I want this router connected to this subnet, connected to that router, and so on, because that's not the things that the application guys care about.
So you could define a policy template, run it past the security team,
right?
Get it approved,
right?
Really?
And you just multiply it as many times as you need for different application stacks.
Yeah. Exactly.
You can
That's the whole point.
Yeah,
Greg will love that.
You can allocate it to a specific group of users, restrict access to it.
And you will see it as part of the demo, right? I define a policy, and then I say, I want the engineering guys to have access to this policy. And I don't want the finance guys to have access to this policy. right? And I want the finance guys to have access to another policy, right? And then they can just pick to instantiate networks based on these policies. That's the concept here.
And you can define the whole application stack with the policy?
Right now, the policy is up to layer 4 rules.
Okay, yeah, of course.
Okay, but yes, up to layer 4, right? It's a policy for the network. Sometimes I say we are good plumbers, right? So it's a policy for the plumbing.
So you can define the policy that says I have 3 subnets and I have this firewall between the first 2 subnets and the load balancer and the firewall between the other 2 subnets?
Right, so I will show you the thing, right? You can define a policy, actually, in the demo you will see is the 1.0 is one release earlier, but the policy, you don't even define subnets, because what tells you that the application tier is just one subnet? It can be 10. What you define is that I have an application, a business logic zone, and I have a web zone, and I have a database zone, and then from the database zone to the business logic zone, I want to go in this way, and from another zone to the other zone, I want to go this way. And then it goes in even more granularity and says, by the way, all the database guys are allowed to attach VMs on the database zone, and all the web guys are allowed to attach machines in the web zone, but not to each other zone.
So you're applying the L4 policy.
Right.
Yeah. Okay. So it's like VApp on steroids.
It's VNetwork on steroids.
VNetwork.
Okay? Now, okay. So I talked about policy and how important it is for us. Now I'm going to try to explain the whole product and put everything together before I go to the other 2 items so that we answer all the questions that I postponed. Okay, so the system has 3 layers, right? At the bottom layer, there is what we call the virtual routing and switching. This is essentially the vSwitch sitting in the hypervisors. And in all transparency, the vSwitch sitting in the hypervisors is essentially an enhancement of the open vSwitch with a lot of other capability we added there. We have what we call the virtualized services controller. That again, remember the analogy, this is essentially the control plane of the router. We pulled it out, we made the virtual machine. And this is actually running the same operating system, the same routing protocols as our service edge router, meaning everything is there, right? Pick a protocol, most likely you will find it in there. And at the top layer, we have what we call the virtualized services directory. And this is where policy is. This is where the policy is, and this is how the policy is applied. And I have my regular example to show you now how the policy is applied, because it was asked a little bit earlier.
So the services controller is actually a virtual instance of your regular routing software.
Yes.
Well, with southbound interfaces and northbound interfaces.
Yeah, yeah.
Exactly, right? It is, and to a certain extent, we are the only ones that dare to do that, right? Or the only networking vendor that dare to get the real service provider routing protocols, right? And now we are making this available to the data center and the enterprise. Now,
yeah, this is important because you fixed all the bugs in the last 20 years while we code.
It's a baked code.
It's 12 years. Don't make us that old, but 12 years. Okay, I think that's good enough.
It's a baked code, right? It's running, I don't know how many hundreds of networks and stuff like that.
It's over 550 service provider networks worldwide with over 250,000 routers in the ground. So it's really hardened OS that we are putting in here.
The key here is that the last 18 months, we didn't have to focus on that. We just had that. We just used that because our friends across the street have been pounding on that for a long time. We're able to focus on the policy.
It's the the EVPN code is new.
Yeah.
Yeah.
Well, it's a new SAFI, but also this code got also deployed in about 2 types of policy management networks, right? A bunch of LTE networks are running this code in the P gateway and the PCRF components, and also in basically DSL networks. So it was implemented 2 times.
Okay, so if a DSL network crashes, you sort of benefit from the bug fix.
In a way.
That's sweet.
Don't think that. Oh my God.
It's the policy part that really makes this solution for me. This focus on the policy, and it moves away from the, the crank and handle and the wind and
this is important that this is actually an old code.
Yes.
As much as you hate BGP,
I don't hate BGP. I just hate everybody's blind subservience to it. Right? We just need to realize that BGP is only a good pretty old hammer.
Okay.
You know, but
I apologize for starting this.
You're backtracking. You just said you liked it, so.
It's an old hammer, it's an old tool, but it solves the problem. But the important thing is the abstraction that you talk about, the policies.
Do I need to reinvent the wheel and make it square this time or not? Right? That's the whole idea. So,
real quick on the L3 piece. So am I hearing that if I need east-west traffic between
VMs,
whatever we're calling it, east-west L3 traffic, that'll be distributed out to the edge. There'll be an instance run there. How does the data plane get driven into that?
I'll show you a slide exactly for that.
Is it like a route flow calculation on the controller, then you manipulate?
Yeah, you know, I had the slide. I hide this. I hid it, but I'm going to show you exactly the slide because I realized there are questions. Okay, but let me finish the policy thing now. The parallel I want to give on how the policy distributes and how it happens is, think of your cell phone, right? So most of you flew away from here. You arrived in the airport. What you didn't do is pick up a landline to call an orchestrator, to tell the orchestrator, I arrived in San Francisco, give me cell phone access in San Francisco. By the way, that's the way it used to be when the first cell phones came arrive. What did you do? You turned on the button. And what happened behind the scenes? Behind the scenes, there is a registration event happening. The registration event is propagated in the network, goes to a policy server, a PCRF, or in the wireless terminology. The PCRF calculates the policy, says, okay, this subscriber came in, he has access to this network, he has access to this type of services, here are the services, push down the services implemented at the edge. It's the exact same concept that I'm going to illustrate that we are doing here with the policy server. Essentially, think of our policy server as an entry where when a VM gets up, it sends a registration, the VM sends a registration event to the network says, a VM came up, I don't know what to do with it, tell me. The policy server says, these are the policies you have to obey, calculates, rehashes the policies, pushes them down, and allows the whole thing to be implemented, right? That's the fundamental concept that we followed from the wireless phones. And by the way, that's how wireless phones work, that's how subscriber management systems work, that's like the standard way of scaling, right? And the reason that we copied this approach is we know it scales, right? It scales to millions and millions of subscribers. So let me quickly find this slide.
To get a bit more technical again.
Yes.
So the cloud management system gives you an event like OpenStack or whatever that this thing is up now. Like OpenStack creates a port. And you go and you fetch the policy. And is that the same code that runs the MPBGP, or is that a separate policy controller?
The policy controller is a different entity.
OK.
It's a different entity.
And then the policy controller downloads something into the relevant hypervisor. No, the policy. I'll just give me 1 second. I'm coming to this exactly this description, right? Good.
I'm coming to this exact description, and I think you will see the whole flow. So, just to make sure that you understand, you asked for all the interfaces, right? So now I'm showing you how the components talk together.
Yeah.
Hypervisors with the virtual switches, OpenFlow and OVSDB, because just OpenFlow is not enough between the controller and the hypervisors. BGP, east-west to federate. I can add more and more controllers. And XMPP to the policy server. You will ask, why XMPP? The reason for XMPP is because it's essentially a pub-sub infrastructure, right? So in this direction, when something gets activated here, I can issue a request to the policy server and figure it out. If somebody goes from the top and changes the policy, then I can use XMPP to push the policy down, right? I can do policy push. Now, on the top, what is not shown in the slide, there is a REST API. So the REST API is used to program the policy server, okay? Now, the whole layer 3 thing. Let me try to explain it on this slide. Okay, so I said what we create for this virtual construct that the application provider sees is essentially we are creating this distributed virtual router and switch. Think of it in a way the same way like the distributed virtual switches, but it's a distributed virtual router and switch. And what it does is you can have 2 subnets here, for example. I have the red subnet and I have the green subnet, right? And this is a distributed entity. So how is packet forwarding happening now in this distributed entity? VM, when the red VM sends a packet to the other red VM, right? The packet comes in the hypervisor. I look at the MAC address of the destination VM. I have the route out of EVPN. I know to which hypervisor to send it. I start a tunnel directly from this hypervisor to this hypervisor. What if the red VM wants to go talk to the green VM? Now, in this case, the red VM, before it can talk to the green VM, is going to ARP for the next hop router. And what we're going to do is we're going to capture the ARP in the hypervisor and respond with a virtual MAC that is the virtual MAC of this router. So we're going to give the VM the virtual MAC for this router. The VM is going to put the packet with source this guy and destination this guy with a destination MAC that is this virtual router, and it will put out the packet in the hypervisor. Packet will come in the hypervisor. Oh, it's for us. We peel out the MAC address. We do a route lookup now. We find that this VM is behind this hypervisor. We rewrite the L2 header. We decrement the TTL, right? And then we encapsulate the packet in a tunnel directly from this hypervisor to this hypervisor. So all the routing decisions are the same distributed way as in line cards, right?
And you do that all with OpenFlow rules?
Yes. Yes.
So you don't have a special layer 3 agent that would do that?
No. So the controller programs all these rules down here, but the user plane of OVS, right, is modified in order to do that stuff. Because the user plane of OVS cannot do that stuff, right? It's modified.
It can, but it would be interesting.
It would be painful.
Yeah, because whoever's replying, so you're saying that's a distributed process on the hypervisor that's doing that reply.
Yes.
So you are effectively capturing the ARPs. The ARPs are coming from the kernel module. They land into the user module. The user module responds.
Yes.
So you don't need an OpenFlow rule for ARP response.
Correct. And then for layer 3 forwarding, we do essentially an IRB processing, right? If you do IRB in a router, it does the same thing. You terminate the MAC address, peel out the header, do routing, put a new MAC address.
Well, you actually do what Cisco was doing with multi-layer switching.
Yes. Right? And we do that.
Install the flow in the kernel.
Right. And we do that in every single hypervisor, right? So when you look.
And that's okay unless you have to go through a firewall or somewhere.
Okay. So let's go. I'll get back to the firewalls, but so this is one virtual router, right? Things like firewalls, load balancers, all these layer 4 services, they are in reality endpoints that are sitting here, right? This VM can be a firewall. So if I want to send traffic to this firewall, I send the traffic to this firewall, and this guy processes it and sends it back and goes wherever it goes, right? All these appliances are essentially endpoints on this plumbing infrastructure.
So are you not doing any service insertion on the edge there?
Okay. So
at least remedial?
Yeah. So the other thing we do here is we do ACLs, right? So we do ACLs on the way out, and actually we do both ingress and egress ACLs. We do ACLs on the way out, as packets come out of the VM to go out, and when packets, just before packets are delivered to a VM, we do ACLs as well. So this gives you a lot of flexibility on what you want to do.
I was just talking about specialized firewall functions or appliance functions.
Yeah, I'm talking about more than ACLs, right?
Do you have the classic ACLs that are totally stateless, or can you insert the flow entries for return traffic?
Right. Right now we have stateless ACLs.
Okay.
But the other ones are coming shortly. Now, one important thing is if you notice this virtual router here, right? Essentially because of MPBGP, it changes routes with up here. So if I need to go up here, you will see in the next slides how tunnels are started directly to go out. Now,
you're getting into tunnels, never mind.
So a little bit on the data path details, right? I'm trying to answer the question. This is the hypervisor. We have a physical NIC or more, whatever, right? And then there is a tenant context, right? So for every tenant can go have a whole bunch of virtual machines there. And then what happens is, for every tenant, there is a obviously different route table, right? A different route table, and then we multiplex everything, and this is the tunnel encapsulation. Now, if you see at our tables, right, we have a full MAC and a full IP table.
Of course.
Right? For everybody, right? So we have for everybody the MAC address and the IP address. For every VM within a tenant context, we have the MAC address and IP address, right?
Now, if you would have a floating IP address, like you have high availability cluster,
yes,
how would you handle that?
It's there is an answer to this madness, actually. there is an answer to this madness. What we do essentially is we track gratuitous ARPs. We move it around.
Okay.
So how does it work with Microsoft NLB?
Yeah.
No, Microsoft, no. I had this fight. I had this fight.
And you won?
And
Hey,
I won for this release. Okay, now, so essentially what happens here is there is a MAC lookup, there is an ACL lookup, a route lookup, and sometimes you can just go out of the MAC lookup if you just have a layer 2 service only. Very important. I didn't realize that. One day I figured it out. Apparently in AWS, when you do VPC and you go between subnets, they don't decrement the TTL.
Of course not.
Right? So that's we actually do decrement the TTL because we might go outside outside our world, right? So that's the data path details. So now let me put everything together. I think that's the most critical slide now that shows you how the whole.
Before we go off the data path,
yes.
So you kind of glossed, when do tunnels get nailed up? And then tendencies, do you
when a tunnel gets nailed up. A tunnel gets nailed up when you get here, when the controller populates a forwarding entry, that if you want to go to this destination, IP or MAC, your next hop hypervisor is this. That's when you get a tunnel to this next hop hypervisor.
When you so you're not building out the topology prior to.
These
completely on demand, right?
These are stateless tunnels.
Stateless, and if I withdraw the routes, then they just go away. Right?
Okay. Yeah. For the local topology, every controller knows what's going on, knows the relationship between tenants and VMs, and builds this. It's auto-discover, right? There is no, I mean, otherwise we wouldn't have been able to move VMs around and remove tunnels automatically. So
yeah, no, I mean, just tunnel setup.
It's just forwarding entries. The tunnels are essentially forwarding entries, right? For this destination IP, add this VXLAN header, right? Or whatever header.
Now that you mentioned moving VMs around, you just opened a new can of worms. I'm sorry.
Go ahead.
Go for it.
Can you move VMs across different controllers, or is it within the controller?
No, across different controllers, right? Because you move the VM to the other controller, BGP learns from this controller.
Yeah, but then you have to deal with eventual consistency.
Right.
Because within the controller, it's fast. Over there, you will lose traffic for some time.
But that was addressed, but it's just that the ATF draft is freaking long. And I think it's crazy to read, in my opinion. I thought we should have split it in 3 parts, so we make it readable. But there is everything is in there, and inside one controller, it's easy to solve, of course. And then everything is there to actually pass it between controller information.
So, and then there is a trick underneath the hood there that because of the sequence of the events happening, and if you time right the sequence of the events together with the VM move, because of the way they do the VM move, right? The VM move, you move the whole VM, and once you move the whole VM, you go back and delete the old VM because you cannot delete the previous VM, right? So you have advanced notice to start doing your work, and then the limits that we see are not, the interruption we see during a VM move between controllers is not significant, right?
Does it have
the one thing you could do is prefix-independent convergence on the edge. So if you get the traffic into the old hypervisor, it forwards it into the new hypervisor.
Yes. That's the other trick.
But the key is, as you noted, the VM moves at L2 or at L3 is a non-issue. Between controllers, it doesn't matter, between DCs.
What about for service?
Don't go there.
What's that?
If you have service insertions, though, then those have to move in state. I mean, what are you doing for?
Right. So again, services. The way you have to think about services, firewalls, and stuff like that is, you can insert a rule that says, if web traffic wants to talk to business logic traffic, send your traffic to a firewall. Essentially, it's a redirect. And what happens in this case is that the rule follows you. Right? So you will always go to the same firewall. Sorry, you are not going to go to the new firewall.
All right. So you're not maintaining any state sets between stateless devices.
Ed, what they do sort of is they have VRFs.
Yes.
And they have different routing tables for different VRFs.
That's it.
So they're just
for the web VRF, the entry to the database VRF goes through the firewall. That's why they enforce it. And as you move things around, it's just VRFs. It works.
Okay.
That's it.
How do you
Same for VPN.
Yeah.
L2 or L3,
Yeah.
we have
You
the
talked
same
about
thing.
the virtual switch. Just I don't want to beat it to death, but how are you doing the physical switch? Is that OVSDB?
Can I come to that?
Yeah, yeah,
Yes.
that'd be great. Please.
Can I ask,
Down the road.
ask how you deal with, or have you run into any issue with BGP convergence time as you're moving a host from
Right.
controller to controller? I mean, BGP is not a fast protocol; it's just
Right. So,
scalable.
so far, to be honest with you, in anything that we have done, we haven't run in any of these issues. And the reason that we are very confident about these things is because this is the same BGP code running these large backbones and large edge networks,
We've
right?
been at that in there for
it's
a
not
long
like
time, so we have
a toy that we just cook to put something together.
Okay, now that you mentioned large, what is your largest production deployment and what's the route churn in that deployment?
I don't think I'm allowed to say that.
I didn't ask who it is.
What's their last production deployment? What I can tell you is what is public, and what is public has to do with the code itself. Right? The BGP code itself runs, 8 million routes and things like that. Right?
I can just give you some dimensions of the size of the networks that this is deployed in. We have this deployed in networks where our routers are about 7,000 routers in the ground, supporting very large scale, and this is deployed in environment. So it's not a VPN environment, but a subscriber triple play environment, and it's supporting millions of subscribers, providing IPTV services. That's one application. In another application for a VPN, we are deployed where there are about 4,000 routers that are deployed. So it's very large-scale deployments, very, very large-scale deployments. And they are scaling beyond that as they add services and subscribers.
Because we all know that the number of routes is not an issue.
Correct.
It's the number of updates per second.
Yeah, well, remember that,
which is small in the global internet or in the VPN, relatively small.
Yeah.
in the VPN world,
And remember,
Yeah, but as you start moving VMs around,
probably about, it could be up to 10 million. And I mean, BGP put in place route target constraints and other mechanisms to actually regulate the flow of information between, one tenant domain, one geographical domain, and the other one, right?
I'll give you actually what are the worst case. Okay? If I try to follow the activation rate or the move rate that OpenStack or any of these tools does, we are about an order of magnitude faster. Just because of the
so
bottleneck
you're
there.
saying they can't do it, so we don't care.
Hold on. I didn't finish. I told you I'm going to tell you the worst case. The worst case is you have a couple of racks, and their top of rack switch goes down, and they go down, and then suddenly their top of rack switch reboots, and then you get 4,000, 10,000 VMs coming up, and you have to churn these VMs. Right? That's the worst case. That's where we are striving to get the maximum. That's where you will get a lot of events, right?
That's the argument he's using with me also, so we don't test networking reactions. We don't need to do that fast, right? But in reality, actually, if you think about it, all of these like thousands of PEs, they actually go pretty fast compared with what you are used with in the data center network in terms of updates and volume of updates. Actually, we are way, way beyond any kind of convergence that you see today in the DC or even from the SDN deployment.
And honestly, we have dealt with the example that Dimitri just gave. We're actually dealing with those kinds of issues because the example of subscriber management and supporting millions of subscribers, what happens when an entire area goes down? You're removing a whole chunk of subscribers off.
It just depends whether you have a route per subscriber or a subnet that covers 1,000 subscribers.
Yeah.
It's of course, it's engineering principles, of course, come in. But the point we are trying to make is, we know how to scale this. And, the one I didn't talk about is mobile backhaul networks, where we are, again, deployed with this. Now you're talking about tens of thousands of routers.
No, but okay. We all know what we're talking about, and his argument was really good.
Yeah.
So the orchestration piece is so slow. Don't worry.
So they are actually, I think if you can get 10 VMs a second to come
Be
up,
realistic.
I think it's kind of the benchmark. Okay. Now, let me show you how this thing comes together, right? So this is the data center network, or across multiple data centers, IP data plane. There can be a provider edge. This is the PE router or whatever that will allow the data centers to interconnect, for example, with an MPLS VPN service or something like that. So you have the whole IP MPLS network control plane, and we have the control plane and the policy plane. And what we do is, on the policy plane, I told you we put our policy server, and that's what controls, who gets what, and what services are allocated. And let's assume that you build here, down here, right, a data center zone. So I start with a cluster, couple of thousand servers. I add the controller to the cluster. So now the controller is going to manage all the forwarding entries on these servers, right? So a single controller can do that. And then I use something like OpenStack, and OpenStack can create the policy or can update the policy. And OpenStack will activate a virtual machine down here. And sorry, I'm in the middle. I'll try to sit down so that I'm not in the middle on the slide. So OpenStack is going to activate a virtual machine down here. When OpenStack activates a virtual machine, our agent in the hypervisor, it's going to receive an event. We register with the hypervisor, we receive an event, this virtual machine is instantiated, what to do with it. The hypervisor goes to the controller and says, give me my routes for this VM. The controller says, I have no clue, goes to the policy server and says, give me my policies and my routes. The policy server now will say, okay, here are the ACLs for this machine, here is the QoS for this machine, here is whatever you need for this machine. And by the way, because this is BGP, VRFs and stuff like that, here is your route target and route distinguisher for this machine. The controller gets all the information now and activates the service, okay? So at this point, I have a service with one machine. Now I get a second machine up, right? The same process happens. The hypervisor says, I have no clue what to do with it, goes to the controller responds, goes to the policy server, figures that out, and now I have both of these guys, both of these virtual machines now connected to the same, if you want, virtual routed and switch domain, right? And now I have connectivity between these machines, right? So this red machine here, this hypervisor knows if I get a packet from one red machine to the other, I create directly a tunnel from one hypervisor to the other. Now, the next thing that the controller does is, because now it has a route target, route distinguisher, it's going to talk BGP. It's going to talk BGP and it's going to talk to the PE, right? That's the only other speaker, BGP speaker over here. So the controller is going to advertise to the PE that for this particular VPN or particular tenant, if you're going to reach the subnet, these are your routes to the subnet. The PE is going to advertise that to the MPLS network, and now I get an end-to-end connectivity, right? So now, if I want to send traffic from this subnet all the way to the enterprise that is sitting on the other side over an MPLS VPN, I know that I have my next hop is the PE, and the PE is going to put the packet in whatever MPLS tunnel it needs to put it on in order to send it to the other side, right? I got the end-to-end connectivity now working for me. And remember I said these are VXLAN, and this, for the time being, is VPN over GRE, and in the near future, when these guys start supporting VXLAN, it can be VXLAN going over all the way to the P. Make sense so far?
And you have to rewrite the next hop on PE router so you don't expose next hops in the data center to the outside world.
Right. So what we do here, we do aggregation, right? So we aggregate all these routes.
Yeah.
Probably the PE will do aggregation of the host, and then could do interface option B or whatever they want to use, right?
Okay. Now, let's assume I do a second data center zone, right? And now this will show you the federation. And what I do in the second data center zone is, let's assume I have VMware in the second data center zone. And what I do there is, for the second data center zone, I add the controller again, right? So I have my own controller now for this data center zone that is completely decoupled from the controller on the other data center zone. And now, when I activate a virtual machine, I make it green here, potentially in a different subnet, it can be in the same or different, that wants to belong to the same enterprise application. What is going to happen is, this controller is going to advertise that this virtual machine here is behind this hypervisor, and this controller is going to advertise already that these machines are behind these hypervisors. So now both controllers synchronize their state, and now the green machine, if the green machine wants to talk to one of the red machines, I can do directly a tunnel from this hypervisor to the corresponding hypervisor, right? So I get the federation. So you see what is the principle here? The principle is actually that when I build a large data center, I usually do cells, right? I will do my availability cell. It can be a container, a couple of thousand servers, whatever. I do it once, I plug the controller, I power it up, and then I start replicating it. And I don't need to do anything else. I start replicating it, and because it's completely uniform, they talk over BGP, I extend my services across the availability zones, right? That's the fundamental principle here.
Do you have a recommended size per zone for your controller?
Yes. Yes. So our controller right now is scaled to up 1,000 virtual machines, right? But when you
no virtual machines.
Sorry, 1,000 servers. Sorry.
1,000 servers.
Big difference.
Thank you. Thank you.
Thank you. Big difference.
So this is at parity. What I was saying before, this is basically a cluster of controllers that can scale individually for a cluster of servers, right? When you want to take it beyond that, automatically it will just go modularly. And those data centers could be across the wide area network, right? The BGP infrastructure in place will distribute it, right?
I mean, this is any IP infrastructure, right? It's not like co-locator.
So your app domain's extended all over.
Exactly.
Okay.
That's right.
But as you do that, where you're approaching the WAN edge there to the PE, now you're essentially doing MPLS layer 3 VPN over GRE over the existing IP infrastructure. Is that correct?
That's right.
Okay.
So that's when we talk to the P.
That's
when we talk to the P.
What that P could be having an internet context, right? It doesn't have to go.
His question was, do you have any empty?
You're doing a lot of encapsulation.
No,
there, so.
there's no issues because most.
No, you stop one and start the other.
It's the same thing, right? It's when you do VXLAN, right? You add the UDP header. When you add the GRE header, is actually smaller. The VPN over GRE header avoids the UDP, so it's actually, I think, 10 bytes smaller or whatever it comes to.
Remember, the whole system is a router. And we are just peering with the PE router at control plane, and then data plane, we are doing the right end cap.
So you are still dependent on the constraints of the underlay, right?
But the PE router is non-issue with regards to the support when we do a VPN over GRE and cap.
So, and actually, we have demonstrated this interoperability with obviously our routers, but we have demonstrated with Juniper and Cisco that it works, right? I mean, because they have been working for a while. Now, the next step is, you asked about...
so the interoperability with Juniper and Cisco would be layer 3 VPN, right?
Yes, because, well, Juniper will have a VPN soon. I hope so. They are
ramping the beat. Don't worry. They will be different, but that's a different story.
So, now,
not a news
gateways. And you want to talk to bare metal servers, there is a need for the gateway. And assume there is a gateway there that can be potentially controlled also by a controller, right? It becomes the same thing. If the tunnel cannot start in the hypervisor, if you have a bare metal server, you obviously need a gateway, and the tunnel needs to start from the gateway, right? If you have a physical infrastructure there. And the question is, what are these gateways? And I'm coming to this, so just spare me a couple of minutes. I will get back to this. So if I activate the service here, it works the same way. Now, the next step is, and I mentioned everything, there is one more fundamental thing happening here, one more infrastructure, right? This policy server, I talked a little bit about it, but it has also, what it has there is it has a big analytics engine as well. So what it does is, for all the statistics, for all the traffic statistics collected in all the hypervisors, we actually use a streaming mechanism to get all the statistics and stream them up to this analytics database. So there is an analytics database that essentially is a scale-out architecture. It's backed by a Hadoop cluster. And it can collect statistics from the hypervisors down to every second interval. Or it can, how many packets were transmitted, bytes, whatever. It can collect, it will aggregate all the statistics. It puts them back in a time series database. It's a database on a Hadoop cluster optimized exactly for this type of data. And it also provides real-time analytics, meaning what we call threshold crossing alarms. You can go set up alarms that say, if the traffic on this subnet exceeds this on the average over a 5-second period, issue me an alarm. And then we are going to issue back an alarm to the application or to whoever is deploying the data center to figure out all the traffic. And then you can also go in and do traffic trending and figure out who is using traffic, where traffic is being used, and all this kind of stuff. Okay, so I covered up to here that all our main components, including the visibility and assurance, and let me finish with the gateways, right? What about gateways? Where do you need hardware gateways? Where do you need something else than the virtual world? And in the most existing solutions that I have seen is, the first thing is, the approach taken often is, you need a gateway to go out, first of all, right? You need a gateway to go out to the internet or whatever, and then the approach that I have seen is, well, put a couple of virtual machines in a gateway rack, and then on the other side do VLANs to go back to the routers, right? And now it's like, we are back at square one. All this work to avoid VLANs, and we're back at VLANs. And the other obviously thing is, I have a top of rack switch there potentially as a gateway, and then I can instantiate my tunnels here on the top of rack switch as opposed to this. Now, what do we do about that stuff? Right? And first of all, remember I explained to go out, we don't need to do anything. We just go out to the P. Right? We do the tunnel to the P, we connect to the VPNs, we got rid of the VLANs, right? No more VLANs anywhere, we don't want to see them. Now, for the top of rack switches, there is still a need for gateways, right? There is still a need to connect to bare metal servers. And honestly, there are two main use cases here, right? There are the bare metal, I have a database, I want to be in bare metal because I have a fiber channel behind it, whatever I have. I think the more often use case that we are encountering is, I'm a hosting provider, I'm transitioning into the cloud, I have lots of customers in my hosting environment, they want their applications that are hosted to be able to the applications that are in the cloud, right? Solve this problem for me. That's, I think, the number one problem. Now, for us also very important is that this gateway here is part of this virtual network domain. Now let me explain what this means. It means that the gateway has to be able to do VRFs layer 2, layer 3, right? Not just layer 2. In other words, the gateway is not VXLAN here, VLAN here. It's VLAN and it can be bridged, but also it can be routed to somewhere else, right? Both layer 2 and layer 3. So, what are the options, right? There are options for software gateways, and honestly, software gateways can work for small data centers, because do an easy calculation. If a software gateway can send 10 to 20 gigabits of traffic, it costs you maybe 3K to build one, to buy one and deploy it, and it's going to cost you about 300 watts of power to pay for.
Good enough.
Right? And you do that, it's going to cost you money, in other words, right? If it's a small installation, good enough. If you are a hosting provider, I'm not so sure, right? Now, we are actually very lucky that the virtualization industry got so much attention that a lot of the generic hardware tools are also now providing an interface to potentially do encapsulation on the top of rack switch, right? And we are seeing some of the features there to be present and some not to be present. The capabilities and trade-offs there are significant. And the third option is dedicated high-performance gateways, okay? And let me talk a little bit about what a dedicated high-performance gateway would look like, right? So we put a set of requirements when we started this whole activity, actually, about what it would look like. It needs to do both layer 2 and layer 3. It's not just an L2 device. In other words, it doesn't just bridge VXLAN to VLANs. It does layer 3 as well. It needs to be able to do multi-tenant services, essentially multiple VRFs and all these things. High-performance control plane, high availability, right? As Ivan said earlier, servers are going to be multi-homed. I'm going to have a virtual chassis type of topology. I cannot start the tunnels from the one side and not from the other side. I have to take care of all these things. It needs to be friendly for the cloud. I can be able to program it. Should be able to do things like Puppet Chef and all these things that people like now in the data center in order to deploy there. And it needs, right, to be a solid gateway. So what have we done for that thing, right? So for the software gateways, we have an offer. It's based on our vSwitch. You just put the vSwitch in a virtual machine with a little bit of wrappers. You get a software gateway. As I said, in some use cases, and you will see increasingly some of these use cases coming from us, this is a very good solution, but it's not the only solution. We are already doing OVSDB and OpenFlow, and we have already started working with third-party hardware manufacturers to allow us to control their gateways by leveraging the OVSDB interfaces that they are doing anyway, right? So this allows us this
Anyone
option.
you can name?
Not right now.
Not right now. You have to wait a little bit.
It's in the works.
It's in the works.
Okay, so who has VXLAN capable hardware these days?
It's probably the same partner list as NSX.
Yeah, a 6-letter company.
Okay, so there are several people. You know the drill, right? Okay, now
everybody has access to the same merchant silicon.
Right. So the interesting thing is what is we are saying in public for the first time.
It's just announced on Twitter.
Yeah, just announced on Twitter.
Now we go.
We thought we would be a little more further ahead with this.
Okay.
So
I already knew.
You already knew.
That's like 20 minutes ago.
Oh my goodness, Twitter is ahead of me. My goodness. So we also actually, when we started building this project, it's not like we did it last month. We realized we need a hardware gateway and we rushed to build one, right? When we started this program, we knew immediately we need a gateway, right? So we actually built from the ground up a gateway. This is a gateway-specific device, right? That it is meant to be the network virtualization edge, right? It is built from the ground up from this. And it's tightly integrated, obviously, to all the other approaches. And we give the option to customers to choose whatever they want, right? So some of our customers have told us, go work with this guy, fine. Some of our customers say, we want a high-performance gateway that meets all the capability of the solutions, and we offer our own gateway. And just as a highlight of what it does full layer 2 and layer 3, meaning when you encapsulate traffic, you can do it at layer 2 and layer 3. It's based on our same operating system as all the other hardware boxes that we have. It has a Linux sandbox where you can put your own stuff. It's a terabit capacity, one RU box. I'm sure you can guess what is behind it. It's merchant silicon plus some stuff. Okay? You can guess why the availability is where there is, but it's not just merchant silicon, it's merchant silicon plus some stuff.
Yeah. And the most important thing is going back to what I said with the interaction with one of the customers this morning is we are now bringing the SDN automation capability to all workloads, virtualized and non-virtualized workloads, and with 3 options. With the software gateway option, which we have already been offering, but now with this ground-up hardware high-performance gateway, we have that covered. Specifically the case that Dimitri was talking about, where you have a managed hosting provider, they want to get a whole bunch of bare metal servers connected to workloads that are virtualized for their customers. That's really the use case that we are seeing.
Yeah. You're going to need different things for different things. You might my current thinking is that you're going to end up with a data center where you have software encapsulated for the for that, but you need the physical. You'll use cheap top of rack stuff for a certain part of your network. Maybe there's for the volume, but where you've got time and energy to validate that they work with your solution, and then there's also going to be a need for the guaranteed stuff.
That's right.
So I see your gateway solving things like this is where the WAN connections are,
That's right.
and that has to work.
Yes.
And you have to be on the hook for that.
That's right.
Right.
Absolutely.
And so I see it sort of as a mix. You're actually saying to the customer, whatever you like, you have it your way. Spend the money that you see fit.
That's it.
Yeah.
And our gateway also is going to provide an OVSDB interface. You can work with her partner.
I mean, because what happens when you have 60,000 MAC key values, right? MAC, I assume MAC to VTEP mapping.
Mm-hmm.
So are you just leveraging CAM and doing it via OpenFlow? And
no, we're not doing it. We are not doing it.
OVSDB.
No, we are not doing it via OpenFlow in the gateway, right?
Okay, so it's just OVSDB instantiating your.
Yeah, it's OVSDB sending the routes, but then we use the capabilities of a regular router to do it. It's not that essentially what they have is when you go underneath the chipsets, you will see that they have a lot of. They can do a lot of IPv4 routes. If they are 32/32 type of routes, they have the capability because it's a hash table. They do a lot of them. They do a lot of MAC addresses. They can do a lot of not so many longest prefix match, right? So they are limited, right? So you hit limitations. We have tried to overcome some of these limitations by doing some things around the merchant silicon. Obviously,
But
you don't get the same flexibility as the software, right? But you get the performance and the cost power trade-off, right? So you're talking about a couple of hundred, whatever it's per port, and 3 watts of power versus 300, right?
But you're not flooding from the gateway to find end hosts. So somewhere that data plane is getting programmed.
Yes.
And it's getting programmed with OVSDB or?
Yes.
Okay.
Well, yes and no, actually. When we are talking about our own gateway, our controller is tightly integrated in the gateway as well. So our controller is managing the endpoints of this particular gateway, right? So our controller is in here. It's running in here. It has a tight software interface because we couldn't do anything else.
Controller?
Yeah, the VSC.
Remember that model we took our controller and those virtual forwarding planes and made a virtual router around it?
So the controller is in there.
Okay.
Yes.
So you have to federate the gateway with the other controller.
Yeah.
It's running MPBGP.
Okay.
Yeah,
I mean,
same way.
Hey,
Right?
cool.
Yeah.
But
You're just doing unicast replication to. It's just another hypervisor.
So you effectively do Mac learning on the LAN side, and whatever you learn, you announce it to the other federated controller. So it's a pure PE router.
Right.
Yes, it's a PE router.
You got
Yeah.
it.
You got
it.
it. Everything-
The chassis became,
everything
the
is
whole
a PE
rack became
router.
a PE router.
Right? So this is a PE router with less hardware capabilities than a high-end.
It's a software PE router.
Yeah, we have enough. Yeah.
Yeah, it's like
passport.
Cisco 3900.
So if the DMAC isn't found locally, he's going to go out to he's going to poll every hypervisor. If they don't return a value,
No,
Oh.
no. The
No,
controller,
there's no bump.
everything
There's no bump
the
traffic.
controller learns.
Right?
This is MPBGP.
Uses
I'm saying
MPBGP.
inside the island.
The controller learns through MPBGP, right? He knows.
Oh, so it's already.
There is no
I'm
unknown
with you.
MAC address.
Now, I'm only 10 minutes late from my schedule, but I think that's good. So I'm going to try to show you some stuff now.
Real quick, what do you advertise performance-wise for your gateway, the software gateway? Just curious.
I don't think it's going to quote a number. It depends on the hardware, right?
Sure,
It depends
no,
on
of
what
course.
hardware you're
So
running.
in terms of, so it's a terabit capacity
No, the
in one
software-
RU.
software.
The software part, MPBGP basically.
No.
The software
gateway.
The software gateway.
Oh, the software. I thought you were talking about
I
the
think,
Tor
look,
gateway.
I think we are going to use, and we are using things like PCI pass-through to enhance the performance. But sometimes we've come across some vendors who are doing special tricks with their NICs. So it varies across different NICs.
It depends.
The performance is
I
quite
think you
variable.
mentioned earlier 10 to 20 gig, which seemed high, so I just want to get...
So I think it depends a lot on the hardware. We have seen hardware that the gateway can easily do 10 gig, right? In some hardware, it can be even higher than that. It depends essentially on the server hardware, and it depends on the NIC and what the NIC does and what the NIC doesn't do, and if it load balances the cores, and it's very server dependent.
I have a rough rule of thumb here. It's more than 1 gigabit and it's less than 10.
It's
Varies
more
on
than
how
one,
many-
less than 40.
That's right. And then it depends on CPUs, which NICs, which drivers, which.
That's right.
Right?
That's it.
So more than 1 for most enterprises is way more than enough.
But a lot of vendors will say it's 2 gig. I just wanted a number for you to say more concretely.
Did
you need a hand?
That's what I can tell you, right? We have seen it in certain hardware, it's up to 10 gig. Again, it's up to 10 gig with 1500 byte packets. Now, depending, there is a whole curve. If you go to lower, smaller packets, you will see smaller.
Well, you really should talk to Intel and discuss DPDK.
I was just going to say that that's the other thing that we can use as
This
well.
is,
We're
no
looking at
matter
it.
what you do in the software gateway, right, you are paying a lot of power
technically deeper
for every gig of processing you do over there. Because with an Intel processor, you never put just an Intel processor. I wish it was so simple, right? It's an Intel processor, south bridge, north bridge, this bridge, the other bridge. It's like whoop.
Video card.
It becomes like that, right? By the time you are done, you are paying a lot of power. And the advantage of the hardware gateways is, it's whatever. It comes down to 3 watts a port, right?
I'm saying you could do a bank of gateways and software, get a cluster of servers, and just have a bank, if there was that many servers, right?
But how much money are you going to pay for that, right?
How much is the gateway?
Well, so Jason, the comparison is this. It's a bank of servers with what you need for that.
Sure.
And it's a viable option. We're not saying we're offering it, but in space versus a hardware optimized gateway where every port can do 10 gig line rate performance.
Guaranteed no matter what packet size.
And you know,
it's trade-off.
And you know the price points
sure. Yeah.
Per port.
I'm sure it's not
10 gig
cheap, you know, that gateway.
data centers.
Yeah, but it's principally for legacy transition, right? So you want it from a 10 gig aggregate in base into your net to extend out what you're doing, or are you?
And it depends. There could be a layer 2 DSLAM on the other end.
Okay. Yeah. Fair enough.
Yeah.
Right.
I mean, it's varied use case, right? So I don't want to say use the one or use the other. I think everything has a use.
Could you throw your gateway and software in Amazon or cloud and federate that somehow?
You could do that as
Absolutely. Absolutely. We have
some
customers that are actually asking us exactly that, and no
Well, you know what? You could deploy CSR on the other end and run MPBGP with this stuff.
well. Okay.
Not touching that one.
Demo time.
He kind of missed that, but it's
Anything
okay.
other vendor, just
So-
move along.
Section 2, demo time. We still have some time. So again, my name is Dimitris Styliadis. I'm the chief architect of Nuage, and we are going to start now and do a simple demonstration of the technology. Before I demo, I'll show you briefly what I'm gonna show you, kind of thing, right? So eventually, I'm gonna create like an application network. I'm gonna use OpenStack actually to create this application network, so that because it's familiar with people, I'm gonna create some virtual machine in OpenStack, make sure they talk to each other and they talk to the enterprise and the public internet. And I'm gonna show you something funky also. I'm going to go also and instantiate some VMware virtual machines and have them attached in the OpenStack networks that I created in OpenStack. And that's you will see how the policy server manages to deal with this. And also I'm going to instantiate a bare metal machine and bring everything together. My physical infrastructure looks like what I showed you before. Essentially, I have 3 controllers. I have 1 controller for OpenStack, 1 controller for VMware, and the 1 controller for the bare metal servers. And I'm going to overlay this topology here to allow this connectivity, and I'm going to also show the connectivity with an MPLS VPN there in the backbone and how everything comes together. Okay?
Does your software gateway support VPN, IPsec?
Not at this point. Okay. So in order to show that, let's start.
There's nothing preventing us from doing that, by the way, because it's the same OS. So the OS of the router supports IPsec.
Okay, so
It's
Right, exactly.
we have a number of features in the controller, including support for IPv6, IPsec, and a number of other things that is just a matter of really putting them through the test machine, because we want the environment to work properly.